Hello everyone, my name is Liu Ye. I am a first-year PhD student at the Hong Kong Polytechnic University. Today I'm going to give you a brief introduction of our paper, Unified Multimodal Transformers for Joint Video Moment Retrieval and Highlight Detection. This work is a collaboration with ARC Lab, Tencent PCG, and Pengcheng Laboratory. In this work, we consider the task of joint video moment retrieval and highlight detection. Here, the input is an untrimmed video and optionally a natural language query. The expected outputs are some video moments in which the visual or audio contents are relevant to the query. In each moment, clip level saliency scores indicating the highlights of this moment are also predicted. We proposed a unified multimodal framework to address this task. Our method is flexible for different modality reliability situations. For example, here's a long input video that contains multiple scenes and can be divided into visual and audio modalities. Leveraging these two types of inputs, our model can predict the fine-grained highlight scores and select the highlight moments marked by the yellow star and the rectangle respectively. When the audio is unavailable and a text query is provided, the model can also retrieve the most relevant moments and highlights. The orange arrows denote the full version of UMT, which takes visual audio information and text queries as inputs, and localizes all the moments while estimating each of the highlights accordingly. Here is the overall architecture of our framework. It derives from the transformer encoder-decoder structure. The input video and text are firstly processed by pre-trained feature extractors. After that, the visual and audio features are fed into separate unimodal encoders to be contextualized under global receptive fields, then be fused by the cross-modal encoder to become visual-audio joint representations. These representations, together with the textual features, are used to generate clip-level moment queries. The moment queries can be utilized to retrieve moments and highlights from joint representations in the query decoder. After decoding query-guided video features, we adopt two prediction heads to obtain the final result. Note that for the cross-modal encoder, previous works typically apply cross-modal attentions to realize feature aggregation, which may propagate noisy information and require higher computational costs. To address these issues, a novel architecture named bottleneck transformer is proposed to disentangle the feature aggregation process into two stages, which are feature compression and feature expansion. We introduced learnable bottleneck tokens to capture the compressed features from both modalities. The feature compression is realized by several multi-head attentions between bottleneck tokens and the features from different modalities, so that the bottleneck tokens can obtain compressed information from them. After compressing the multimodal information, we expand the features and propagate them into each modality using inverted multi-head attentions. The expanded features are then fed into feed-forward networks for further projection. Leveraging such a two-stage feature propagation across modalities, visual and audio features are augmented under linear computational complexities, while also avoiding incorporating noisy information. We compare our method with some representative ones on 4 datasets. Table 1 shows the results on QV Highlights dataset. This dataset contains daily vlogs and news videos. It is the only one that supports joint video moment retrieval and highlight detection. Our method outperforms the previous ones by a large margin. Table 2 displays the moment retrieval results on Shiraz STA dataset. We tried two types of modality combinations. Both variants obtain better results than existing counterparts. We also evaluate UMT on the highlight detection task on YouTube highlights and TV sum datasets. The text queries are unavailable or unreliable in these two datasets. The comparisons above demonstrate that our approach can handle different modality conditions and combinations, showing the effectiveness on multiple tasks under various settings. Here are some visualizations of the results. In Figure A, the frames denote the moment retrieved by our model. Rectangles in different colors show that our model can learn implicit correlations between video content and query semantics. Figure B indicates that different modality combinations guide the model to pay attention to different moments, demonstrating the necessity of multimodal learning for these tasks. Figure C shows that our model can handle multiple queries in a single video. So this is a brief introduction of our work. Please feel free to contact us for any further questions. Thanks for your listening.